Yeah, thanks, Gavin. Yeah, so as Gavin kind of said, I'm going to give a talk around continuous deployment and going from 0 to nothing. It's a tech demo-based talk, so a lot of it will be code. So thank you to the people, to everyone that's stayed on till now. And I'm going to show you some code as well. So yeah, my background, I joined a startup as their first employee, first software developer, got given a spec to say, we want to make an application that does this. This is our idea by two founders. We scaled that organization, went through the different journeys of scaling, the different operations requirements, as you can imagine, going through that. Finished up with them as head of development. Was then employed, yes, it was in the job title, as a DevOps consultant for a consultancy. Worked at a government project, part of the GDS scheme, if anybody's come across that. And also on a personal level, I co-organised DevOps Manchester. So if anybody's ever up in the Northwest, we run a DevOps Manchester meetup, community meetup group. More recently, this is my corporate slide. I've set up my own business with a business partner called CLOS, and we focus on technical scaling and people scaling. So it's actually with a lady that was previously in HR. So we focus on scaling your organisation from both the technical operations requirements and the all-important people element of that. That's it. I won't do any more. Who uses, just before I go on, who uses Docker? Who's aware of Docker? Just put your hand up. Right, I won't do the Docker piece then. Everybody's aware of that. I'll cover off a little bit about Google Cloud. Kubernetes, who is aware of Kubernetes and uses it? I'll cover a little bit of that then. And then also the technical stack, and we'll do, like I said, a tech demo. What I won't cover, a lot of the talks I do tend to be cultural aspects of DevOps or scaling, but I won't cover whether what impact it will have on your organisation of doing something like this, or even whether you should do something that you're about to see in terms of the tech. Also, should caveat what in terms of the code, all the code's available, we'll see that in a sec. It's not production ready, so if you do clone down some of the code that we're going to see, I would definitely start to harden it, and it's definitely proof of concept. So a bit inspired by Dave's talk yesterday, if anybody went to that, I thought I'd just tell the journey of this talk itself, iterations of feedback loops. Started it off, done an internal business presentation, rambled on at loads of people that probably didn't want to listen to me. Iteration 2, did a Docker meetup, and the tech demo worked. Faced quite difficult questions at that one. Iteration 3 was going great. I probably got a bit cocky. The tech demo didn't work. Google had changed some stuff. 4, did a conference in Manchester, reviewed my cowboy attitude to the tech demo, and decided to do a test. Still refused to pre-record the video. And 5 is London, and I'm now wearing a headset, which kind of, I've made it now. Currently resisting, I said before, currently resisting the urge to sing Britney Spears songs. So, for anybody, we're going to see some of the code, but for anybody, it is 4 o'clock, switches off. All the code is on my GitHub account, and it will just work. It's Google Cloud at the moment, but it's not, most of it is vendor neutral. So it doesn't have to be Google Cloud, it's just the thing that gets your Kubernetes cluster is Google Cloud specific at the moment. So Docker I'll skip over, because I think we've talked about Docker enough for the last 2 days. So for anybody, who uses Google Cloud? Play with it, cool. AWS? A few more. So Google Cloud, similar to AWS, certain kind of thing. I suppose the only key difference for me with Google Cloud is they'll collect, when you go into AWS, you get presented all the resources you can create. With Google Cloud, it's similar, but they tie all your resources to projects. So you create a Google Cloud project, and then all your resources are associated with that project. So it kind of takes a project-based approach. That's one of the main differences. A lot of the other things you can get on AWS, you can get on Google Cloud. I tend to work more in AWS, terms of the clients we work with, but obviously this talk's based out of Google Cloud. Various things Google Cloud has is App Engine, that's like EC2. Container Engine is Kubernetes, essentially. It's like AWS's ECS. You have Bigtable, SQL, you have storage, BigQuery, PubSub messaging, all various kind of services that you can also get on AWS. So in terms of Kubernetes, Kamal covered a little bit of this in his talk as well, but essentially it's an open source. Google have contributed a lot to it, but it's an open source for deployment, scaling, and management of your containerized applications. So in the same way that you might deploy a Docker container and you do some port mappings on your host, when you start to need more versions of that Docker container or more replicas hanging around and start to manage all those ports, it starts to get a little bit more complicated. Kubernetes helps you with those kind of things. It does failure tolerance, so if a container fails, it will bring it back up. It does automatic scaling, deployments, and a lot of the kind of self-healing things that you need to run an enterprise application. And it does work, so I'm usually quite skeptical of these kind of clustering tools and seeing them work. But from my experience thus far, having run Kubernetes in production, it does work, and the load balancing and failure tolerance, it is as solid as kind of some of the material you read. So some of the concepts in Kubernetes is a cluster, and that is a Kubernetes cluster will have nodes within that cluster. And a node is basically a physical or virtual machine by which your pods can be scheduled. So your cluster is made up, you've got a cluster that is made up of nodes, and then pods contain containers. So a pod has all your Docker containers within it, or you can have multiple pods. And then services are almost that layer before your containers. So if you've got, let's say, Nginx web server or a node application or something like that, you can put a service in front of that will proxy traffic through to those various containers. And you can do it on a round-robin fashion and things like that. And your service kind of sits at that layer above. So your service might expose port 80 to Nginx, and then it proxies down to the various Docker containers that can deal with that request. So this is the kind of typical example you see. So you have a Kubernetes master that kind of orchestrates things. The red label there is a service that is load balancing between two pods, and both of those pods can provide that service. That one there's a service that has a single pod with Docker containers within it. The fact that, and obviously this is your cluster, each node is a separate virtual machine or separate physical instance. So, for example there, if this node goes down, Kubernetes knows that it will schedule traffic to that pod. So, in terms of the demo today, what we're going to do is, I'll jump through this actually, just go back. Run a shell script that will provision us a Kubernetes cluster. Now this provisions it on Google Cloud, so it uses the Google Cloud native tooling, but it's just a bash script that provisions a cluster. It then deploys Jenkins onto that cluster, which is, it deploys Jenkins by taking a Docker image of Jenkins. It's a pre-configured Docker image on Docker Hub that is also pre-configured with a Jenkins job. The Jenkins master will then start, and it gives us an IP address which we all should be able to visit, provisioned in the cloud. It will then trigger a build of an application that I've written, which is a Java Spring Boot application, and build that application, and then also deploy that as a Docker image into the same same Kubernetes cluster, and it will give us an IP for that. So it's literally 0 to continuous deployment, just releasing something out. The really important bit, has anybody faced an issue with scaling out build agents, whether it's Jenkins or any CI/CD server? Yeah. So one of the nice features of the running Jenkins on a cluster or the build agents is the build agents that run are provisioned as Docker containers into the Kubernetes cluster. And what I mean by that is they exist, so your build agents exist for only the period of time that your build is running, and then the container's destroyed. So you no longer have to maintain build agents. They just spin up at the time of the build, and then they get destroyed, and we'll see that shortly. Let's jump back here. So yeah, we're going to run a deploy script. That spins it up, and we'll show some of this code as well whilst I'm running it. Docker image, again, all these links are in the slides, so you can grab them once the slides are shared. That's pre-configured with all the required Jenkins plugins and things that we're going to use. A Jenkins slave that gets spun up. And the application is just a crude kind of Spring Boot application. It says hello world, basically. So, before I go into this bit, I'm just going to start the app. So the script essentially, we just give it some input variables there, but we're running the script. We're telling which Google Cloud project to use, where we want our instances, our nodes in that cluster to be deployed, what the machine size is, like you would do in EC2, and how many nodes, so agent machines in a Kubernetes cluster, we want that to make up of. And then the last file is how Google manages kind of access to machines. So that's it's called a service account in Google Cloud Platform, and that gets stored as a Kubernetes secret within the cluster. So I'll just kick that off. It'll ask me to log in. Okay, so it just tells us that we're going to provision a container cluster in that location with. Okay. Okay, so that's going to go ahead and kind of create as a Google Cloud container cluster, so Kubernetes essentially. Okay, and I'll kind of go back over what that's doing. So what's about to happen is running the shell script. That will provision Google Container Engine, like I said, which is Kubernetes. Once that's provisioned, it configures our kubectl command line tool, and that's how you interact with a Kubernetes cluster, run Kubernetes commands. That kubectl tool then deploys Jenkins onto that cluster. So moving down to kind of stage 4. And what we do is pull a publicly available image that I've created from Docker Hub, and it provisions it into the cluster as a Docker image, as a pod. So up to kind of number 5. So that Jenkins image has been pre-configured with the various plugins that we need in order to do this. So one of them is a Kubernetes plugin, and that allows us to run build agents as Docker containers, ephemeral build agents, basically. Also the Git plugin and things like that, various kind of requirements that we need to pull down the code. So Jenkins then fetches the pipeline defined as code. So if anybody's used Jenkins files, that's essentially what I mean there. So it'll go ahead and fetch the code, the build pipeline defined as code from the GitHub repository. And then it uses step number 7, it will run that build for us. So it uses the Kubernetes plugin to then spin up a Jenkins JNLP slave, so a build agent essentially, Within that build agent, it will execute the build. So because it's a Java application, what I mean by that is it will run Maven build. Doesn't run any tests or anything like that. I'm a dev. It will run that build for us. It also packages it up as a Docker image, which I think comes down here. Yeah. So runs the build for us. It packages it up as a Docker image. Up here. And pushes that into container registry. So Google also have like AWS, a container registry, and it will package that application up as a Docker image with a tag of the current date and time, and pushes that into the container registry. And then it uses, coming back round to the end, it uses that Docker image to then deploy that application out onto the cluster using the tagged version that we've just done. So that's a lot to get through. Has anybody got any questions at that stage? I know there's a question and answer at the end. No? Does everybody just want to see it working? Yeah. Yeah. So with the Kubernetes, so it uses the Kubernetes plugin for provisioning the resources in the build process. The actual deploying the resources at the end, the slave that it uses, this JNLP slave, has already got Kubernetes installed on it, so just the kubectl command line. Yeah. The other kind of, one of the nice things you can do with the Kubernetes plugin, this example doesn't do it, but you can use different Docker containers for different stages of your build. So let's say you were deploying a single page application and you know that the first thing you do is npm install. You can use the node image as part of the Kubernetes plugin to do the npm install bit part of your build. And then you can use, let's say it then goes into Nginx or something like that. You can use the Nginx part of your, use the Nginx image to do the web server part of your deployment. And it mounts the source code of your application within each container. So for example, of this one, I could run the Maven part of the Java build in a Maven Docker image, and then the Docker part of the build that builds the image of the application in a Docker image that already has, so Docker in Docker. It already has Docker installed. So the script will have provisioned as a Google Cloud Kubernetes cluster, and we should be able to visit that now. This is where I kind of stand back and say, yes, it's not production ready because there was no username or password on that. So what that's done is provision the things we've said basically. It's provisioned as a Jenkins cluster, started up the build. If I go into here, the other thing I should be able to do on here is so that's our Kubernetes cluster, and we should see in a moment the pod that will do the build will start up on that cluster. You can see the various, so here it is. So this second one that's container creating, that's our build agent starting up because Jenkins has triggered it. That will start up and execute our build. Once the build's completed, that pod will go. So that build agent no longer lives there. And we'll show some of the code that does this. So if we go into here, once that pod started up, should see the build start to trigger now. Yeah, so that's the Jenkins pipeline starting. So at the moment we're kind of checking out the code and compiling it and getting ready to deploy it. So whilst that's running, just bring that up. I'll just go through some of the code that kind of does certain things. So can everybody see that? So go a bit bigger. Yeah, so this is the bash script, the deploy script that starts up the cluster. Essentially, it uses the Google Cloud, just wraps Google Cloud's command line interface and spins up the cluster. So this bit is kind of the main guts of the bash script, really. But that will spin us up a Kubernetes cluster. For anybody that's on AWS, one of the tooling I've found really useful is COPS. So if you're looking at a Kubernetes cluster on AWS, COPS seems to be a nice transition for that. What that then does is take in an argument that we replace, so that GCP project value, and it deploys the Jenkins master onto it, and that's the Kubernetes YAML that will deploy that. Like I say, it's off my public GitHub account. The ports section at the bottom exposes the ports for us. So Jenkins will listen on 8080, and 50,000 is for the Jenkins slaves. So while we're back, so yeah, we've pushed the image to Google Container Registry, and we're just waiting for the external IP. So if we pop that open. So that's the application. You should be able to visit that on your phones, or that's the extent of my design skills as well. Jumping back to the code a little bit more. So another nice feature of deploying Kubernetes in public cloud, and this translates for Azure, AWS, and Google Cloud, is you can do things like set type to load balancer. What that will do is actually provision a external load balancer within the cloud platform. So it might be an ELB on AWS or an actual load balancer on Google Cloud. Like Kamal's talked earlier on, nowadays you use things called Kubernetes ingress instead of exposing services externally. This just still does that. And what that's doing there is saying anything that comes over port 80, I want you to target onto port 8080, which is our Jenkins master, and look for services that are called Jenkins server. So if we go back to this Jenkins pod, there's a service name called Jenkins server, and that's how that service knows which pod should respond to that traffic. In terms of the application itself, so the application, how to build the application is kept alongside the actual application itself. So the Jenkins file that defines the stages also defines how to build it. So this syntax here at the top, that's used by the Kubernetes plugin. What that's telling us is which image to use, which image to use for different containers. So this one here is an image I've created, and it's the JNLP Jenkins image, and then we use that later on. So we say no JNLP. So what we're telling Jenkins there is run the subsequent build steps of this pipeline within that Docker container. So we first of all check out the image, Maven compile, Maven package, build the image, push it up to the container registry. Then we do a Kubernetes deployment of that application, do a bit of sed scripting, and then I do terrible kind of wait loop till I get that external IP address, and then cat that out to the screen just so for the purposes of the demo. So one of the things you can do is, at the moment, all those stages run within the same Docker image, but you could have multiple container templates here, one for Maven, one for Docker, one for Node, whatever are the requirements of your build, and then actually wrap each stage within those containers. So instead of the node being at the level that I've got it there, you could have node around stage Maven clean compile, and you could say node Maven, do the Maven clean compile, and then you could say node Docker, do the Docker build stage of it. So each of those stages there, you'll see map on. Who uses Jenkins files for deployments? A few. Each of those stages there map onto each of the stages we've created there. So proofs in the kind of put in with the continuous deployment bit, just to finish off in the last bits of the code. That's the Docker image for the application. So the application just adds a compiled Spring Boot to the directory. It's based off Java, the Java base image, and it will just deploy that. It just runs Java-jar to start up the application. It's just a Spring Boot app. So if we, oh yeah, and as you can see, the build container's now gone. So we've only got the Jenkins master running. And we've got our actual application, because we've got 2 replicas of that, we've got up and running as well. So if we now open up, I'm going to just do it in Vi. We should see Jenkins automatically kind of spot that change and start the build pipeline again and deploy another Docker image onto the same URL, same IP address. He says. So whilst we wait for that, is there any questions from anyone? So no. So it uses Kubernetes deployments. For Kubernetes deployments, it will you can specify a revision history limit, which if you don't specify it, it means it keeps all of them. And when it will use a Kubernetes deployment, so what that means is roll this new version out, and you can do health checks and things like that as well. So it will keep a revision of the previous version, so you can always roll back with Kubernetes deployments. It doesn't because the Docker tag that gets issued when you push the image at that stage, because the Docker tag it's time and second based, so it's like year in ISO format. It pushes a new Docker image, so you always have that previous Docker image as well. So yeah, it doesn't remove them, and you can can either use Kubernetes deployments to roll back or just redeploy the previous Docker image as well. Cool. So if we refresh that, at some point, there you go. Phew. Yeah. So no, yeah, it doesn't go. Any other questions from anyone? I could dig into some of the code a bit more as well, if anybody. Nope. I think that's. Yeah, so what we've finished off with is a Spring Boot application that's living on the cluster, Jenkins master, and the build agents have kind of gone. Yeah. Yeah. Thank you. Thanks for listening.